Dear student, today we are going to learn about flash type analog to digital converter. This analog to digital converter is also called simultaneous type or parallel analog to digital converter, and it is the fastest type analog to digital converter. These are ideal for larger bandwidth applications such as satellite communication, radar processing, and oscilloscope, etc. But they consume more power and much bigger in size in comparative to other analog to digital converters. So student, these flash type analog to digital converters are based on the principle of comparator, but in the circuitry they require a large number of comparators, therefore the circuitry will be larger. So as you can see, so let's start with the working principle of this flash type A by D converter. Here this is the, as you can see here in this circuitry, this is the combination of the comparators. Here are three comparators. This is the reference voltage V, and this is the analog input voltage V in. So here the non-inverting terminal of this comparator is connected, all the non-inverting terminal of these comparators are connected to this input voltage V in, and all the resistance are connected to this reference voltage V, and the inverting terminal of this comparator is connected to these reference voltages, that is V by 4, 2V by 4 and 3V by 4. These are calculated by apply the resistive voltage divider network. So we will find these values by applying the resistive voltage divider network. So this input voltage will be compared here, and the output of comparator is applied to these encoded circuitry. So this encoded circuitry is the combination of two AND gate and XNOR gate here. So here this is the basic circuitry of the flash type A by D converter. So here how to calculate the total number of comparators are required in the circuitry. So let us consider the 2-bit flash type A by D converter, because this is the formula here, 2 raised to power n minus 1. This n is the number of bit. So here we will consider the 2-bit flash type. So this is will be equal to 2 raised to power 2 minus 1, and this will be equal to 4 minus 1, and this is equal to 3. So this flash ADC consists of a comparator, resistive ladder network, and digital encoder. Here the comparator compares the input voltage with the reference voltage. The resistive ladder network, acts as a voltage divider, and it produces the reference voltage to the comparator, and the encoder is used to get the digital output. So this is the basic circuitry, and here this is the basic introduction. And now the non-inverting terminal inputs of all the three comparators are connected to the analog input voltage. We have already discussed in the circuitry. This is the detailed description of that circuitry, and the inverting terminal are connected to a set reference voltage, that is V by 4, 2V by 4 and 3V by 4. We have already discussed, and how to calculate these terminals voltages, reference voltages. So here we will apply the resistive voltage divider network. So this is the resistive divider network here, and how to calculate this V1. This V1 will be equal to R upon R plus 3R into reference voltage, that is V. So here in this circuitry, as you can see here, this is the if we calculate the V1, if suppose this is the terminal V1, this is V2 and this is V3, and if this is V1, then V1 will be equal to the resistance, and across the voltage, that will be reference voltage is V, and upon the total resistance, that will be 4R. So here these are the 4 resistances, 1, 2, 3 and 4. So this is divided by 4R. So this will be equal to like this, v1 equal to v by 4. Now let's come on v2, and this v2 will be here v by 2, because there are the two resistances, and upon total resistance is 4R, and across voltage will be resistance voltage, this reference voltage, sorry, this will be v, and this will be now calculated, this will becomes v by 2. Now similarly we will find out the v3. This will equal to R plus R plus R upon 4R. This will be the total resistance in the circuitry. So the total resistance in the circuitry will be 4R into the reference voltage, that will be V, and this will be equal to 3V by 4. So here according to this circuitry, this if we calculate the V2, there is two resistances, and if we will calculate this V3, there will be three resistances. So these are the uh, resistive divider network rule. So here we will calculate the V1, V2 and V3. So now let's come on the operation. So here if V in, that is the input voltage of the comparator, that will be applied at the non-inverting terminal of comparator, that is V in, and that will be equal to the greater than to the reference voltage of the comparator, then the output of comparator goes high. Goes high means here the output of comparator is in positive saturation, and if the V in is less than the reference voltage, then the output of comparator goes low, means the comparator goes in the negative saturation. So if we will consider here the first condition, if suppose when V in is less than V by 4, so how to consider this term? According to this table here, this is the analog input V in, and this will be lies between these values. We suppose the first one condition is V in. Here the V in is in between 0 to V by 4, means V in is less than V by 4, then the output of the comparator will be 0 0 0, and the digital output will becomes 0 0. Now if the V in input voltage of the comparator will be in between V by 4 and 2V by 4, that will become V by 2, then the comparator output will be 1 0 0, and the digital output will becomes 0 1. Now when the V in is lies in between 2V by 4 and 3V by 4, then the comparator output will be what, 1 1 1 1 1 0, and this will becomes the digital output is 1 0. So here if the V in is lies between 3V by 4 and the reference voltage, then the comparator output will be 1 1 1, and the digital output will becomes now 1 1. So this is the so this is explained here in complete detail. When if the first one condition V in is less than V by 4, so in this case the voltage at the non-inverting terminal of all the three comparators is less than the respective voltages at inverting terminal, and hence the comparator outputs are C1, C2, C3 equal to 0 0 0. We have already explained, and the digital output will become B2 B1, that will be equal to 0 0. So similarly when we calculate the V that is between V by 4 and V by 2, then the comparator output will become this 1 0 0, and the digital output is V2 B1 equal to 0 1. According to that table, these four stages will be calculated. So these are the four stages of this flash type A by D converter, and this is the basic working of this comparator. Now the advantages and disadvantages of this flash type A by D converter. So here these are the some advantages of this converter. Here it is the fastest type of ADC. The construction is simple and easier to design. suitable for larger bandwidth applications such as satellite communication, radar processing, oscilloscope, etc. Compared to all ADCs, the flash ADC performs the conversion at very high speed and its capacity of sampling rate up to gigabytes. So these are the advantages, and now let's come on the disadvantages of the flash type ADC. So here these are the some disadvantages. It is not suitable for higher number of bits, higher power consumption is here, limited resolution, large die area is required because to raise to power n minus 1. So there are huge number of comparators are required. So these are the basic disadvantages. Thank you.